Okay, Wildcats. Today we're looking at Wednesday, January 31st, cube and cube root inverses on page 51. All right, if you would update your table of contents. Now your table of contents are updated. Let's take a look at your notes. All right, so cube and cube root inverses on page 51. There are 4 ways to find the inverse. First, graph, reflect over the y equals x line. 2, table, switch the x and y. 3, algebraic, switch x and y and resolve for y. All right, now for the 4th way, use composition functions. When f of g or fg of x is x and g of f, which is g of f of x, is equal to x, we can say the result of f and g of f is x, then we can say f of x and g of x are inverses. And the note, domain and range will switch. All right, if you would update your notes. All right, now your notes are updated. Let's take a look at the examples. Now, I'm going to color code as a graph, so f of x will be in blue, and the inverse will be in yellow. Now, we're going to graph a little differently because we need the points so we can switch them for the inverse, okay? So we're going to use the direction to find those points, but we're not going to graph by direction. All right, so here we know that the vertex goes up 5, so we go up 1, 2, 3, 4, 5. And then graphing by direction, we know that we go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. Left 1, down 1, right 1, up 1, and we don't need to go there. So we kind of graph by direction, but we're actually going to put the points so we can switch them for the inverse. So our points are -2, -3, -1, 1, 2, 3, 4, and so -1, 4, 0, 5, and 1, 1, 2, 3, 4, 5, 6, 1, 6. All right, so in our notes, a little awkward long pause, we know that all we have to do for the inverse is switch the x and y. So the new y's are -3, or the new x's, I'm sorry, -3, 4, 5, 6. And the new y's are -2, -1, 0, 1. Before I forget, let's finish graphing f of x. All right, and now let's graph the inverse. So we go -3, and then we go 4, -1, and then 5, 0, and then 6, 1. All right, as you're finishing up that, I think someone's at the door. Let me get that and I'll be right back. Sorry, I'm making video.
I have a list I've got to go. It didn't have features, and I just had the students, so I don't know what to look at. Okay. All right, sir. Thank you.
All right. So there you go. I had some time to reflect, pause time. I apologize. The person at the door kept knocking and they wouldn't go away. So I had to go into the door. All right. So example 2. Oh, almost forgot. We want to show that it reflects over the y equals x line. So y equals x is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, and so on. And you can see that it does reflect over the y equals x line, so these are in fact inverses. All right, so now let's look at example 2. And again, we're going to graph example 2 in blue and the inverse in yellow. So, and again, we're going to graph by direction, but we're actually going to label our points so we can switch them for the inverse. All right, so the -2 means we go right 2 and then up 3. So 1, 2, 3. And then we know it's a cube root, so we actually go left 8. 1, 2, 3, 4, 5, 6, 7, 8. Down 2. And then we go left 1, down 1, right 1, up 1, right 1, 2, 3, 4, 5, 6, 7, 8, up 2. So our points are negative 1, 2, 3, 4, 5, 6, negative 6, 1, 1, 2, 2, 3, 3, 1, 2, 3, 4, and then 10, 1, 2, 3, 4, 5. So 10, 5. All right, so let's graph that. All right, so then we did that with the point, so then for the inverse, all we have to do is switch. So our y's become x, so the 1, 2, 3, 4, 5. And our x's become y, so negative 6, 1, 2, 3, 10. Until we graph. So then we go, our point is 1, negative 6. So 1, 1, 2, 3, 4, 5, 6. 2, 1, 3, 2, 4, 3, and 5, 10. So 1, 2, 3, 4, 5, 1, 2, 3, 10. All right, and then we graph the y equals x line. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. And we can see that it reflects over the y equals x line. So they are inverses. All right, now let's look at example 3. All right, find the inverse of each function. So to find the inverse, first we change f of x to y, and then we switch the x and y. Okay, so then x equals negative parentheses y plus 3 cubed minus 4. And then we solve for y. And just draw some lines real quick. All right, so then we add 4 to both sides. So then we have x plus 4 equals, I'm going to put a 1 there, negative 1 y plus 3 cubed. Okay. And then we want to divide both sides by negative 1. And so then that becomes negative 1x. And actually, you know what? No, I'm not gonna do it that way. You can do that. You can actually divide the negative 1, but I'm going to keep it that way. Okay, so then I have x plus 4 divided by negative 1 equals y plus 3 cubed. Okay, then we're going to cube root both sides. Okay, I'm going to have to bring the work up there because we're out of space. So that becomes the cube root of x plus 4 divided by the cube root of negative 1 equals y plus 3. And then our last step is we're going to subtract 3 from both sides. So then I'm going to change the y. I'm going to put the y on the left. So y equals the cube root of x plus 4 divided by negative 1, because the cube root of negative 1 is negative 1, minus 3. And so then I can put that in front. So then that's y equals negative 1 times the cube root of x plus 4 minus 3. And you want to make sure that that minus is outside of the cube root symbol. And the reason why we didn't divide here, because that negative 1 tells us that it reflects over the x-axis, and the 1 tells us that there's no vertical compression or vertical stretch, and we kept the transformation correct at x plus 4. All right. So now, example 4. And at this point, if you understood example 3, you could stop the video now and you wouldn't have to watch these. But if you feel like you still need to watch the video, by all means you can. And you can also remember that if you get stuck on one, I can always go over them in class, okay? All right, example 4. Looks like there's a mistake. Let's just correct it by putting equals y. All right, so first step is switch x and y. So then that's y minus 1 cubed minus 1 equals x. And then we're going to resolve for y. So we add 1 to both sides. So then we get y minus 1 cubed equals x plus 1. We're not going to cube root both sides. Becomes the power of 1 to get y minus 1 equals a cube root of x plus 1. Last step, add 1 to both sides. So then y equals the cube root of x plus 1 plus 1. All right, let's look at example 5. Before you do that, set some lines. I'm blaming the person that knocked on the door for me not having lines on the paper. So I apologize that it took some time out of the video. And me talking about the lines taking extending the time of the video, so I'm sorry. So let me stop talking and let's move on to the example 5. All right, so f of x is y. Okay, so then you switch x and y. So x equals 2 cube root of y plus 3 minus 1. So the first step, and I've shown kind of the steps in greater detail in example 3 and 4, but let me show you kind of how you can go through the steps and not show everything. So you can add 1 to both sides. You can just show this. X plus 1 equals 2 cube root of y plus 3. And then you can divide both sides by 2, so you get x plus 1 divided by 2. 2 divided by 2 is 1, so that's just 1 cube root of y plus 3. Okay, and then our next step is we're going to cube both sides. And so then you get x plus 1 cubed, and 2 cubed is 8, equals, that becomes the power of 1, y plus 3. And then your last step is subtract 3 from both sides. So y equals x plus 1 cubed divided by 8 minus 3. Actually, we're going to do the boxes just there. All right, now let's look at example 6. So again, f of x is y. So then you switch the x and y. So x equals cube root of y minus 3. All right, next step is cube both sides. So you get x cubed equals, that becomes the power of 1, y minus 3. Add 3 to both sides. You get x cubed plus 3 equals y, which I think it'd be good to rewrite it with y on the left. So y equals x cubed plus 3. All right, so go ahead and finish up examples 3 through 6. All right, now let's look at example 7. Determine by composition whether each pair of functions are inverses. Now I did it with color last time I did this, but I'm just going to do it with just pencil this time. Okay, so we do f of g, which is f g of x, which means we're going to put g of x into x. Okay, so then that's parentheses the cube root of x minus 3 plus 3 cubed. You can see here that there's no way that you'll just get x. So since f of g of x will not equal x, we can say that f of x and g of x are not inverses. All right, so with that, again, you have two options at this point. If you understood all examples, start working on the assignment. Not wait to class and ask some questions, and I'll go over any examples you'd like. Either way, as always, have a wonderful Wildcat day.